Hello everyone, welcome to our second video of our computer science series. This series will follow the AP Computer Science A curriculum from Collegeboard as we talked about in the previous video, but you can also use it as an introductory course to learn coding. All the code is done in Java, so all the information will adhere to that. So if you watched the last video, we talked about variables and data types, so today we will discuss the syntax for that. We will also cover arithmetic expressions and what all is acceptable in Java in regards to that. So let's get into the video, but before that, please make sure to subscribe to the STEM Spot for more STEM content. Let's get started. Okay, so let's start first by talking about what syntax even is. Syntax is essentially the format that the code must be written in order for the compiler to understand it. It is essentially the grammar of coding, if you want to think of it like that. Syntax is very case sensitive, so you should make sure that you get it accurately, otherwise you're going to have an error and it's very frustrating. So when you're declaring and initializing a variable, you must use the syntax given here at the top. So there's two possible methods to this. You can either start by declaring the data type followed by the variable name, which should be unique and descriptive name that no other variable in your code has. Then you're going to end that statement with a semicolon. Move on to your next line of code and type your variable name again exactly as you had declared it in the beginning. And then you're going to type an equal sign and initialize your variable with a value of the same data type assigned. And then you're going to end the statement with a semicolon, as every statement in Java is ended with a semicolon. So every time you write a new line of code, just put a semicolon after it. The second method simply combines these two steps into one line as shown here, so it kind of basically simplifies this. And when you start coding more complex problems, you will start to see where you would have to use both methods depending on the situation. So now here are just some examples on how to declare and initialize the variables without errors. You can see that I've given an example of an int, and then the variable name, and then the value. And same thing for the double and even a boolean. You can see that any kind of variable will follow this structure, and you can even do it with either method that was shown in the beginning. Now, one thing I want you to notice is how the variable name is written. There are no spaces, and you will notice that the first letter is lowercase and the starting letter of each new word is uppercase. This format is known as camel case, and this is how professional code is written, and it really just keeps the code neat. You're not going to have any errors if you don't, follow the camel case, but, typically in a code it's written like that, and it just keeps it a lot more organized. So, yeah. So now let's talk about arithmetic expression. You've learned how to declare and initialize these variables, but there must be some way that we should be allowed to, create arithmetic expressions in Java to utilize in the code. So just like in math, Java does allow us to perform arithmetic expressions using PEMDAS. So below here are the very basic operators that you would need to do this kind of arithmetic expression. There are more, but we'll talk about those in a later video because they're a little more complicated. So to begin with, we have just a regular old addition symbol, which is pretty self-explanatory. It's just the addition of two numbers. And same thing with the subtraction symbol. You'll see here that that just indicates the subtraction of two numbers. Now we come to multiplication, and you'll notice that it's not your typical X or dot that you might see in math, but it's actually the asterisk symbol. So that's the way of signifying that you want to multiply two numbers together, is just by putting an asterisk. Next, we have the division symbol. Again, pretty self-explanatory with the slash. This just divides the two numbers that you have there. And this fifth operator, you might have seen this, but it's not very common. But this is known as modulus, and this basically returns the remainder. So it won't return what the answer to the division is, but what's left over. So say you're doing 9 mod 3, it's gonna return 0 because 3 goes into 9 3 times with no remainder. So we'll see more of how this works with the examples in the rest of the slideshow. But for now, that's a pretty basic understanding, and most of these are pretty self-explanatory. So Let's do some practice problems to get used to doing this arithmetic. So let's start off with this first one here. It's a pretty basic, arithmetic expression. So I'm just going to give you a second. You can pause the video for each one of these and try to figure it out. And then I'm going to reveal the answer and then we'll go through why it is. So just pause the video now if you would like to try it yourself. Okay, so if you've gotten a chance to try it yourself, hopefully you got the answer, which was 5. If you didn't, let me explain to you how you get that answer. So, if you notice here, we're following PEMDAS, right? So, if you follow PEMDAS, you know that the P stands for parentheses. So, you always do what's in the parentheses first. And here you can see 5 minus 10 is in the parentheses. So, that should be negative 5. Now, after that, you just follow PEMDAS again, which is just, basic left to right addition and subtraction. So here you would just do 4 minus 5 plus 6, which should get you the answer of 5. Now, the next one, this has now a data type of double. So hopefully you were able to get the answer of 10.4. So again, another pretty self-explanatory one where you can see that you just add 7 and 3.4 and you should get the answer 10.4. And there, if you notice something here, you'll see that there's actually an int inside the double. Now, that doesn't cause any errors right now because there's actually a type conversion that happens where this int becomes a double temporarily. Again, that's more of just the specifics. We're not really going to get into that right now, but just know that it's allowed to have an int in a double. So, again, pretty self explanatory. This just adds up to 10.4 and it'll return a double. Now, here's this third one. This one's a little bit interesting. Let's see if you were able to pick up on this, but the answer was actually an error. So you're going to get an error for incompatible types because if you notice here, we have a double inside the int. So if you try to put a double inside the int can only take an int value, and you can't do type conversion from a double to an int inside an int. You can so the point I'm trying to make here is that you can have an integer inside a double, but you can't have a double inside an integer. And again, there's a lot of logistics behind that, but for now, that's all you have to know. So hopefully you're able to get these three. So let's move on to some harder examples. Okay. So now we have a little bit of multiplication, addition, and division. So again, I'm going to give you some time. Just pause this video and answer the three, and then I'm going to reveal the answers and we'll see how you did. Okay, so hopefully you got a chance to, work those out on your own. So let's just start one by one. For the first one, hopefully you got an answer of 10. So again, we're just going to work through this one like we did the previous ones. Starting with PEMDAS, parentheses always comes first no matter what the other symbols are. You see that parentheses, you do this, you're going to get 6. Now from here, it's just like left to right, you know, addition and subtraction. It works the same for multiplication and division. So now you're going to do 5 times 5 times 6 divided by 3, which is going to get you 2. 6 divided by 3 is going to get you 2, and then 5 times 2 will get you 10. So that's how you're going to get that answer. So for the next one, hopefully you got the answer of 6.0. So here I just made a little note here about the you can use an int in a double, but not a double in an int. That was just kind of like your little reminder from the previous slide. But yeah, I want you guys to notice something here. Do you see how when you're doing this double division here, you've got 4.0 divided by 2? That's going to yield you an answer of 2.0. Even though you're dividing by an int, you're still going to get an answer that returns in a double. Because as long as one of the terms that's being divided is a double, your answer is going to be a double. If both your terms are, say integers or something, then you're just going to be return an int. But in this case, one of your terms is a double. So it's going to return this value as a double. And this times 3 is just 6. And again, with the whole int thing, you know that this doesn't return any errors. So now for this one, again, it's a similar concept I explained at the in the second one, but you're gonna be able to get your answer of 5.0 divided by 3 in double form. So this means that this is actually going to return like, um whatever 5 divided by 3 is in its actual decimal form. So it's not going to simplify this, it's not going to like cut off the rest of the decimals. It's going to return that big long decimal, of whatever this is. So this would be like what, 1/2, right? That's what it would be in its mixed fraction form, which will simplify down to this decimal, and then you're just adding by 4. You're going to get this answer of 5.666 with a really long decimal. So there you can see again how the double division works. Even when you have like a little remainder left over, it's going to translate over in decimal form, and you're going to see that. All right, so this is the last set of examples, I promise. And these are a little more complicated because they do use modulus, but I think you guys will be able to handle it. Just remember that modulus is remainder. And with that, how about you guys try these out too? Pause it for a second, do them, and then I'll reveal the answers. Okay, so now that you have all your answers written down, let's go through these one by one. So for the first one, hopefully you got the answer 0. Point 0. So I'm going to explain to you how this happens. As we see here, 9 mod 3, we know that 3 goes into 9 3 times, so that's just going to give you a remainder of 0. Now you know that anything times 0 is going to give you 0. So that's just why the answer is 0. But if you notice, if you wrote down that the answer was just 0, that's actually not going to be correct because you see that this is returning a double, not an int. So because it's returning a double, we need to do 0. Point 0, not just 0. That's something really important to note here. So for the next one, this one was a little more tough because maybe you didn't know what to do with the whole 2 divided by 3. But the answer is actually going to be 1. So if you see here, 2 divided by 3, they're both in integer form, right? So 2 divided by 3 is just going to do int division. Despite being in a double, it's still going to do int division. So 2 divided by 3 is actually 0 because there's no double here to make it whatever 0.66. It's only 2 divided by 3, so you're going to get 0 because that's what it is in int division. Int can't hold decimals, so it just returns 0. And then we know that for mod 3, the remainder is going to be 1 because 3 can go into 4 only one time. So we're left with a remainder of 1. So the answer is returning a double of 1.0. And that's how you get to that one. So the most important thing to notice here was that 2 divided by 3, when you're doing int division, you're just going to get an answer of 0 because you can't have 0.66 as an int. But if say there was a 2.0 divided by 3 or 2 divided by 3.0, then you would get 0.66. All right, so for this final one here, I guess I ended up explaining it in this first one, but you can see here you should have gone 1.666, big long decimal 5. So there you can see that when you divide by 2.0, or sorry, you divide 2.0 divided by 3, you have that double in there, which is actually going to give you that really long decimal. And then we're just adding 1 to it from this 4 mod 3, as it was this exact same as the previous problem, but now we're just, you know, um, utilizing this double division instead. So hopefully you were able to see those different various patterns, and maybe this was a lot more clear to you. Okay, so thank you so much for watching this video. We really appreciate it. Hopefully you were able to learn a lot more about the syntax of the data types and variables. So you should have learned 2 methods on how to do that, and later we'll see how to use those 2 methods. And then we also got a pretty good introductory course to the new arithmetic expressions, which are going to be very important for doing various kinds of math in Java, and some conditionals, which we'll learn about later. So thank you for watching, and please make sure to subscribe to our channel for more helpful computer science videos and more STEM subjects. Bye.